We're going to take a look at particle motion from a table. So we're given a time and velocity table, and this tells you that the units are meters per minute. Question 8 says, at time of 0, is the particle moving right or left? And justify. Well, remember that direction is given by the sign of velocity. If velocity is negative, then the particle is moving to the left. If velocity is positive, you're moving to the right. So in this case, since our velocity is a -3 at a time of 0, the particle is moving left. So at time equals 0, the particle is moving left. And there's always that justify. You've got to give a reason. Because v of t is less than 0. That's all you have to write. Part B, is there a time during the interval from 0 to 12 when the particle is at rest? And explain. So we know the particle is at rest if it's not moving left or right, which means that your velocity is 0. Is there a time on this table where our velocity is 0? Yes, and that happens here between 0 and 2. Do you see how our velocity changes from a -3 to 2? So by the IVT, I believe, we're going to have a velocity of 0. So here's my answer. Yes, there is a time when the particle is at rest. Let me write that down. There is a time when the particle is at rest. And that is by the IVT, the intermediate value theorem, from earlier in Unit 1 or 2, I don't know, Unit 1. We can say v of 0 is less than 0, which is less than v of 2. So we know that at v of 0, we're at -3, v of 2, we're at 2, so we know we're going to have rest somewhere in here. 0 must fall in between. However, this only works if it's continuous. But particle motion is continuous. And the motion of the particle by the IVT, there exists a time between 0 and 2 such that v of t is equal to 0. So let me finish my explanation. Since particle motion is continuous, by the IVT, there exists a time between 0 and 2 such that v of t is equal to 0. All right, next part. Use the data from the table to find an approximate for the v prime of 10. So let's see, and explain the meaning of v prime of 10. So let's see, show the computations that lead to your answer and indicate units of measure. So use the data from the table to find an approximate use. So, well, that is the derivative at a time of 10. And so we're looking for an approximate, so we're going to use points on either side of 10, and we're going to use, of course, 8 and 12. Okay, so let's calculate the slope of the secant line. So in this case, it's going to be the change in velocity over the change in time. And so 5 minus 7 over 12 minus 8. And this is going to give you -2 over 4, which is -1/2. And this is acceleration. And so this is meters per minute squared. Part D, find the average acceleration of the particle for between 8 and 12 minutes. Explain what this number means in terms of the particle's velocity. So the average acceleration, this is the same answer as the previous question. The only difference is that v prime of 10 is an approximate because it's the slope of a secant line. Well, whereas the acceleration is the instantaneous rate of change, so it's an exact. So let's see what we want to write. It says average acceleration is not an approximate. So it is going to be -1/2 meters per minute squared. And that is our answer. It's the same, using the same calculations as above. It's just, it's not an approximate, it's an exact. It's the average acceleration is the derivative of velocity, which is the instantaneous rate of change. All right, let's take a look at the next one. Part E, let A of t denote the acceleration of the particle at time t, such that v prime of t is A of t. Is there guaranteed to be a time t equals c in the interval from 0 to 12 such that A of c is equal to 0? All right, so what's going on here on this chart? Let's see, we can see that the velocity is increasing, it's increasing, it's increasing, and then it's decreasing. So this means that acceleration is changing from positive to negative. Acceleration is the slope of velocity. So you must have a 0 somewhere in here because we're increasing, and then we're decreasing. So we can say yes, because v of t changes from increasing to decreasing on this interval. Okay, so let's go ahead and look at it graphically. So we've got a time of 0, 2, 5, 6, 8, 12. I don't know. And our velocity starts out somewhere down here at -3, and it goes all the way up here to 7 somewhere. And so I'm just going to do a quick sketch of this. This is what our little guy is doing. It's increasing, and then it's increasing a little bit more. It goes to 3, and then over here it's going to go up a little to 5, and then at 8 we're increasing even more to 7, and then right here, then we're decreasing back to 5. So we see a tangent line right here would be 0 because we go from an increasing function to a decreasing function. And so that would answer. Okay, I want to skip this problem just because we've worked through a problem like that. I want to look one more from a graphical perspective. Particle motion from a velocity graph. This is the graph represents the velocity in feet per second. And let's go ahead and just do that. Feet, and this is seconds. A particle moving along x-axis over time from 0 to 9 seconds. At t equals 4, is the particle moving to the right or to the left? All right, so all we have to do is we have to figure out where is 4. 4 on our graph is right here and somewhere up here. And since velocity is a positive number, remember all of this guy right here, we're moving right, and all of these guys down here, we're moving left. Okay, so at a time of 4, particle moving right. My favorite word, justify, because v of t is greater than 0. Okay, at what times is the particle at rest? Well, remember, rest is when v of t is equal to 0. And v of t is equal to 0 at time, let's see, 5 and 7. Okay, and that's it. At what time does the particle change directions? Well, at t is equal to 7, And that is because we're moving to the right. All this whole time we're moving to the right. We're still moving to the right here. We're moving to the right. And then all of a sudden we hit 0 and then we change signs. So we are moving to the left now between, and if we're only looking at from 0 to 9, I don't even have to look at this little piece right here. From 0 to 9, this is all left. So at time of 7, because v of t changes signs, changes from positive to negative. All right, next question. On what open intervals between 0 and 9 is the particle moving left? Well, the particle is moving left when velocity is less than 0. So moving particle, moving left from t is equal to 7, greater than 7, less than 9, because v of t is less than 0. What is the acceleration of the particle at time equals 4? So that is the acceleration is the derivative of velocity. So we need to find the derivative, the slope, at a time of 4. Well, lucky for us, we have some endpoints on our graph, and I believe this is 312, and then of course down here we have the point 50, so we need the rate of change of velocity. So that's just our slope formula. So y2 minus y1 over x2 minus x1, so negative 12 over 2, which is negative 6. And this is, again, let's see, I believe this was feet per second. There we go, negative 6 feet per second. And it's to show your work. Okay, so what is the acceleration? Acceleration is the slope of velocity. And so it's on this segment here, so 2 endpoints. All of the points on this line have that same slope, negative 6 feet per second. Part F, on what intervals from 0 to 9 is the acceleration of the particle positive? Remember, acceleration is the slope of velocity. So anywhere on this graph where we have a positive slope, and so let's see, this section right in here, this has a positive slope, and then this little piece right in here has a positive slope. So from 0 to 3 and 5 to 6, we can say acceleration is positive because v of t is increasing. Part G, what is the average acceleration of the particle over the interval from 3 to 6? Show the computation that lead to your answer and indicate units of measure. So the average acceleration is the slope of the secant line. So average, let me write this down. Average acceleration is the slope of the secant line, right? And we're looking at between 3 and 6. So the coordinates for 3 are 312, and at time of 6, we're at 6,2. Now that's actually supposed to be a 2, so this is 6,2. So let's find our slope. So we have 2 minus 12 over 6 minus 3, and that's going to give you negative 10 over 3, and that is feet per second squared. Acceleration is units squared. Part H, on what open intervals from 0 to 9 is the speed of the particle decreasing? Well, the speed is decreasing if the velocity is positive and decreasing. Remember, we're talking about when our signs are opposite. So this guy right here, if we take a look at him, he's got a negative slope. And remember, this is our v of t function. So v of t is positive, but the rate of change of this, the slope of this, is negative. So our speed is going to be decreasing between 3 and 5. So between 3 and 5. And where else? Okay, so then we have also this guy right in here. Okay, so see, we are a positive value. V of t is positive, greater than 0, but its slope, the a of t, the derivative of velocity, the slope of this piece right here is negative, is decreasing. So, and between t is equal to 5 and t is equal to 6, and that's because v of t is greater than 0 and a of t is less than 0. So our justification, because our signs are opposite. And we're not going to consider this piece right here because we're only looking at the interval between 0 and 9. We would also be decreasing because we are negative. V of t is negative, however, our a of t, the slope of this guy, is positive. But it's out of our interval, so we're going to ignore that for now. Without knowing the initial position of the particle, is it still possible to determine the time at which the particle is farthest right for between 0 and 9? All right, so remember, we're moving right when our velocity is positive. So from starting at a time of 0, we're moving to the right, we're moving to the right, we're moving, all of this is moving to the right, moving to the right, and moving to the right. At a time of 7, that's when we change direction and we start moving left. So the furthest right is going to be at a time of 7. So we are moving right between a time of 0 and time of 7. After 7, the particle moves left. So at a time of 7, we are at the farthest right. Okay, I think that's it for this problem.